Hello again and welcome to part 4 of my review for the Gossen Metrawatt Metrahit Ultra. This is a model number 248B. What we're going to be doing today is looking at the peak detect. You can see on our Fluke 97 I'm applying a 1 Hz square wave. This is 50% duty cycle, and this has an output voltage of both plus and minus 1 volt. So currently I have all 5 of these meters attached together in parallel, and we're just going to be applying this 1 Hz waveform to all of these. And let's just have a look at the min-max values that these are able to capture. So to collect this data, all these meters behave just a little bit differently. On the Bryman BM869S, you can see I've selected the DC volts, and then I select the crest mode, and you can see it's displaying 1.007 volts positive and a negative 1.020 volts. With the EX540, you can see I selected the volts AC, and then I press the peak hold, and in the upper left we can see the maximum of 1.052 and a minimum of minus 1.058. Then for the Unity UT181A, we place the meter in the volts DC mode, and then in the menu I just select peak, and you can see we're reading a maximum of 1.013 and a minimum of minus 1.007. For the TPI 194.2, again we've selected DC volts, and I select the 1 millisecond peak mode, and again we have a maximum of 0.9881 and a minimum of a negative 0.9929. And again for the Metrahit, we would select the volts DC, I select the min-max, and then in the upper left you can see it's currently set to the maximum value, and this is 0.99475. If I select this again, it goes to the minimum, and now it's displaying a negative 0.99001. So it looks like all 5 meters are basically reading plus or minus 1 volt. So again, looking at the Fluke 97, you can see what I've done now is I've induced an offset. Instead of being plus or minus 1 volt, we are now plus 1.5 volts and a negative 0.5 volts. And here we can see the Bryman is reading plus 1.507 and a negative 0.526. You can see these meters all have to be reset. And here we can see again on the EX540 we have a maximum of 1.549 and a minimum of a negative 0.559. With the UT181A, again we'll just select the peak, and again very accurate, so plus 1.501 and a negative 0.503. And for the TPI 194, you can see it has a maximum of 1.4868 and a minimum of a negative 0.4932. And we can see it showing a negative 0.9577 and a positive 4.8827. It's a little difficult to see the display on this, especially if you're working from a distance, but again, this being more of an engineering type meter, I think they believe that you're normally going to be working close by the meter. So you can see I've changed the duty cycle of the waveform. This is still at 1 Hertz, but I'm now outputting basically a 10 millisecond wide pulse. And again, this still has a peak amplitude of 1.5 volts and a negative amplitude of negative 0.5 volts. There you go, the Bryman's having no trouble with this at 1.495 and a negative 0.528. And again, let's have a look at our EX540. We can see the maximum is 1.465 and a minimum of a negative 0.570. And the 181A looks like 1.492 and a negative 0.503. Very accurate. And again, let's try our TPI 194. You can see the TPI 194 seems to be having a problem with this. It seems like I ran into this before when I actually benchmarked this meter, that it couldn't actually read the 1 millisecond wide pulses. So let's try it now with the Gossen Metrawatt. Looks pretty good. So negative 0.4963. Oh, and here's our maximum, negative 0.33192. So again, unfortunately, this meter cannot resolve a 10 millisecond wide pulse. So unfortunately, it looks like our Gossen Metrawatt M248B is quite a bit slower than the Unity 181A, the X-Tech EX540, and the Bryman BM869S. Let's, for fun, we'll shorten that pulse down a little bit further. You can see we're now at 500 microseconds per division, and we are basically putting out a 1 millisecond wide pulse. Again, this has a positive amplitude of 1.5 volts and a minimum of a negative 0.5 volts. So let's have a look. We'll see if our meters can pick this up or not. Alright, let's have a look here at the BM869S. You can see it's showing a positive 1.502 and a negative 0.530. The X-Tech EX540 showing a maximum of 1.490 and a minimum of a negative 0.518. Looks like the Unity 181A is showing a maximum of 1.501 and a minimum of a negative 0.510. You can see the TPI 194-2 is showing a minimum of negative 0.502 and a maximum of a negative 0.4807. And it looks like our Gossen Metrawatt is reading a maximum of a negative 0.4633 and a minimum of a negative 0.49629. So these two meters, not even in the ballpark. Again, this X-Tech EX540 comes in a nice plastic case with the RF link. Cost on this is about $300. But again, Ruby Electronics recently was selling the real SEM version for $120, and that was shipped. So very nice meter for the price. The Bryman BM869S, again costing about $230. Of course, that doesn't include the software or the data link cable to tie it to the PC. That would cost you, I think it's like an additional $50. The 181A, again, this is about a $300 meter and comes with all the cables and software. Then we have the Gossen Metrawatt, which costs about $850, and that does not include tax or shipping. Unfortunately, the price on this TPI was quite high as well for what it is. And again, this meter has been damaged, but it doesn't affect these particular measurements. Alright, so currently, off to the left, you can see I have our high voltage power supply. It looks like the documentation for the Metrahit shows it's only rated for 600 volts. What I'll do is just start to increase the voltage, and let's see if there's any problems. You can see the warning light for the TPI 194 and the UT 181A both come on at 30 volts. You can see the symbol right here and in the upper left here. and it looks like the Metrahit comes on at 40 volts. I believe this is our Metrahit. Well, that's interesting. You see this? You cannot turn the meter off. It's like the voltage is so high. Let's try it here. Now look at this. Even at 500 volts, it will not allow me to turn the power off. As soon as the voltage falls below, let's just try that again. So there it's set. We'll turn it off. And now as I drop below the 40 volts, is that where it's going to turn off at? Sure enough. It's kind of an interesting feature. I've never seen a meter like that before. So let's go ahead and we'll take it back on up. And here it overranges. Looks like right at 619 volts or so. I guess it rolls right at 620. What I'm going to do is apply a high voltage AC waveform. This will be at 60 Hertz. Unfortunately, I don't have the ability to drive all these meters in parallel, so I'll just use the Bryman and the Metrahit. But you can see I am outputting roughly 540 volts in the upper right of the Bryman. Again, it's at 60 Hertz. And you can see it has a AC plus DC voltage of 736 volts. What I'm going to do is adjust our DC offset now. And let's try it with our AC plus DC. Yeah, there we go. So 546, 546. No problems at all. Let's try it with the AC volts again. Let's just see if there's any effect. You can see I'm changing the bias on this quite a bit. We're all the way up to almost 700 volts. Of course, our Metrahit probably can't handle this, because it's going to exceed our 600 volt limit. And it looks like the Metrahit is not having any problems with that. Currently all 5 meters are attached in parallel. You can see they're connected to my ARB. You can see currently I am outputting a 60 Hertz sine wave. What I'm going to do is run through some different patterns, and let's just see if the RMS to DC converter on this has any kind of quirks. This may be difficult to tell, but this is a stepped waveform, similar to what you would have with DAC. Hopefully you can see this, but it's essentially a square wave, and you can see we have quite a bit of ringing at the edges. See Yeah, I don't see any real big problems with the converter in this one. Looks pretty good. All the meters appear basically on par with one another. I think that's going to be it for this video. I know a few of you are probably getting pretty antsy to see the insides of these. What I don't want to have happen is where I take this thing apart and then decide to run another test and then have somebody call foul that I've had the meter apart and possibly damaged it. So I think what I'd like to do is just request that if you have something that you'd like to see me do with this meter before we start tearing it apart, feel free to add it to the comments and we'll see about going ahead and running that test for you. I've had people in the past ask me after I've run tests on these meters if I could run a certain test for them, and unfortunately I think what people fail to realize is that the vast majority of the meters that I run are permanently damaged and they end up getting recycled. I think I'm running about maybe 30% of the meters is all that actually either survive the testing or I'm able to repair them. Some meters, again, like this TPI, which are damaged, I will still use it for some of these reviews, but there's a few things that I can't actually do with the meter anymore. So again, I think that's going to be it for this video. Feel free to leave your own ideas on what you'd like to see done with this Metrahit next. Thanks.